So the function we have is f of x equals x cubed minus 5 is 1 to 1. We want to find its inverse and check the answer. So again, if I look at f of x equals x cubed minus 5, the first thing we're seeing is cube. The second thing we're seeing is subtract 5. So if I reverse that, I need to add 5 and then cube root the answer. So my inverse should be then, so the inverse of the function should be, we want to add 5 to x, and then we want to cube root all of that. So we should be looking at that as our answer. Now, remember, if we want to find the inverse, we can switch the rows of x and y. So I could say y equals x cubed minus 5 is the original function. To find the inverse, we want to switch the rows of x and y. So where there's the y, there's the x, and where there's the x, there's the y. So we have this y cubed minus 5 is equal to x. And to solve for y, we got to add the 5 to the other side. And then to take the cube root, we have to use this symbol here. And remember, cube and cube root are inverse operations, so they cancel out. They get your y by yourself. And then over here we have the cube root of x plus 5. So that kind of verifies our thinking. Now, cube and cube root do not have any boundaries either, because remember, cube kind of goes like a snake this way, and cube root is a snake that goes the other way. So all we really have is some transformations to it, but that doesn't really affect the domain on a cube or cube root. So again, we're kind of in luck with this one. So the domain of the original function is going to, so the inverse function I should put right here. So the cube root of x plus 5 was the inverse. So then we had no domain restrictions, so that's that. Range is the same way, no range restrictions. Now parabolas and square roots do have those, and we just didn't have that example here. So that's going to be real numbers again. Real numbers again. So again, to graph this, if we look at y equals the cube root of x minus 5 to start with. Yeah, x cubed minus 5. Remember, it's a snake. So if I want to plot a few points, we could just put, 1 in, 1 cubed is 1. And then minus 5, 1 minus 5 would be a negative 4. 0 would go in, that would just give me a negative 5. And negative 1 goes in, that's going to be a negative 1 minus 5 be a negative 6. So for the first function, we should have like a 1, negative 4. So write 1, down 4. This one looks pretty good here. 1, negative 4. That's my snake that I'm talking about there. So this one looks like that's matching that just fine. So the inverse function, y equals the cube root of x plus 5. I actually don't have to make those order pairs. All I got to do really is just switch the rows of x and y. So if I put a negative 4 in, I should get a 1. So notice that negative 4 plus 5 is 1, and the cube root of 1 would be 1. If you put a negative 5 in, negative 5 plus 5 is 0, and the cube root of 0 would still be 0. And negative 6 goes in, notice that you should get a negative 1. Because negative 6 plus 5 is going to be a negative 1, and the cube root of negative 1 would be a negative 1. So do we have a negative 4, 1 over here? Negative 4, 1. This looks pretty good. So that's kind of mirroring what we're talking about. Notice how it's also symmetric to the line y equals x. Notice here, these graphs are not symmetric to the line y equals x. These graphs are not symmetric to the line y equals x. And these graphs are not symmetric to the line y equals x. So that's that thing that's an identifier, is this one. Notice how there's a mirroring across the line y equals x. That kind of helps us out there. All right, that concludes a lesson on inverse functions.